All right, so very good evening, guys. Yes, very गुड इवनिंग गाइस। एक बार आवाज चेक कर लेते हैं फटाफट से। हम्म वेरी गुड इवनिंग गाइस। फैंटास्टिक। आवाज आ रही है ठीक से। एंड आज जिस चीज को हम स्टार्ट करने वाले हैं दैट इज समथिंग विच इज कॉल्ड एज the basics of organic chemistry, the beautiful basics of organic chemistry, wherein we will see each one on what is the concept, electrophile, nucleophile, homolytic, heterolytic, many more things that will happen. Just that we start in a minute from now. Right. Fine. The audio is clear. I think the audio stands clear for now. And video also is more or less clear, right? So we quickly change on the colors for the white segment because we are dealing with the light background for now. 1 minute and we start again. So what is your beautiful color, guys? Your favorite color? I'll just add that. So please add this color, sir. Okay, which color you want? So that is, so this is being very confusing, sir, in terms of colors, sir. Please make it simple, sir. Please, sir. It is equal to my girlfriend's confusion, sir. Okay. All right. I'm so sorry. Okay, Nasa, please don't get personal, sir. No, please not personal. All right. Anyway, so now we quickly start with it, and then we are on the topic which is called as basics of organic chemistry. The most beautiful, most elegant, most important chapter of organic is this chapter itself. Remember, I am not calling it general organic chemistry per se. No, I am not doing that. Rather, I am calling it basics of organic chemistry, wherein I will talk about the basics that you would have done in class 8th, ninth, 10th. You came to 11th and then 12th also. A sum of all the basics that you would have come across is what I will talk about in this session. In a session more like this, and then a practice session similar to this also. So it's almost say 14-15 hours of basics of organic chemistry that once you are through it, you are through it for organic. Basics you are done and you are done. This is how this session is planned for. What I will cover, what is organic chemistry, very layman words, why does it happen so? Then my second question to you would be the bond, which is covalent bond, types of bond, and I'll focus more on the covalent here because we are formed by sharing of bonds. Then we also talk about types of bond cleavage, which is called as homolytic, heterolytic. Bond cleavage is what we will focus on in this session. And we also talk about the attacking species. That is, we talk about electrophile, nucleophile, and those things. At the same time, we a little talk about something which is called as electron displacement effect. And this is where your the basic foundation lies in this chapter, wherein we will talk about the most important inductive, resonance, and hyperconjugation effect. More focus will be on inductive and resonance because we are just kicking off with the organic, and that is where the basics of inductive plus I minus I, resonance plus R minus R, lone pair, hyperconjugation, then your benzene ring, what is resonance, conjugation, aromaticity, all those things we talk about here, right? So inductive effect, two types, which is plus I and minus I, and then resonance, which is plus R and minus R, is what we talk about in this session. All right, this is where the agenda of the session today, almost gonna be 3.5, 4 hours of session, covering all the important technicalities within this here. We'll take a 10 minutes break also in half of it, and then we will continue it. Long session, keep your earphones plugged in at a lower volume because it's a long session, so your ears should not pain. But keep your notebook ready because tons of things are there which you have to note. All right, chal. We start now. Say what is organic chemistry? And in very simple, very layman language is what we talk about, that the chemistry of carbon and its compounds. The chemistry of carbon and its compounds is called as organic chemistry. So if I look back at my class 10th books, the chapter called as carbon and its compounds. In some boards, state boards, it could be class 9th also, carbon and its compounds. So that carbon and its compounds and carbon and its relevant, hydrocarbons, alkanes, alkenes, all those things, aldehydes, ketones, have one thing in common, and that is called as carbon. So if something calls if someone comes and asks you what is your organic chemistry, the first answer that I must get is the organic chemistry is the chemistry of carbon. Right? Most important. Why? Why this chemistry of carbon is so huge? Why chemistry of carbon is so huge? Has two reasons to play. Has two reasons to play. Number one, the first reason is called as tetravalency. What is called as tetravalency? Sir, carbon has atomic number 6, 2, 4. These four valence electrons, neither can it take 4 nor can give 4. Why I am mentioning it that way? Neither can it take 4. The technical word would be very high electron gain enthalpy. Please let us talk about in technical terms also. Sir, I have 2 comma 4. I need 4 electrons to complete my octet, right? 4 valence electrons. The story is to complete the octet, comma, neither can it take 4 because electron gain enthalpy will be very high, right? Nor can give 4 means very high ionization enthalpy. Sir, whenever I have to give electrons, it is ionization enthalpy. Whenever I have to take electrons, it is electron gain enthalpy. All right. In this scenario, the way out is the solution to the problem is that it can share the electrons, to complete the octet. So when I have to share the electrons, it opens multiple doors to me. यानी कि solution is that it can share electrons to complete the octet and therefore forms covalent bonds. Sir, why carbon doesn't form so many ionic bonds? Why? Sir, because the bond with carbon, if it has to complete its octet through ionic bonding, very high value of electron gain enthalpy and very high value of ionization enthalpy. Both means both. All right. So the first reason why carbon forms tons of compounds, sir, it is hidden behind you. Okay, take a note and copy in a second. So why carbon forms multi-millions of compounds? The first reason is your tetravalency. Now, what is going to be my second and the technical reason is called as catenation. Remember, catenation is not just the property. I hope it is noted. I hope it is noted. Remember, catenation is not just the property of carbon. No, even carbon, then silicon, phosphorus, all these metals, non-metals catenate. However, the extent of catenation is highest in carbon. However, the extent of catenation is highest in carbon. Extent of catenation is highest in carbon. Right? And how do I define that, sir? Sir, my catenation is called self-linking property. That is the tendency of carbon. That is the tendency of carbon to form multiple bonds with the carbon atoms, multiple bonds to form uh, multiple bonds with the other carbon atoms, with the other carbon atoms will be called as your your catenation. I want high carbon, both of these are carbon, they have tendency to form the bond. Both of these are carbon, they have tendency to form the bond. This is called as catenation. High carbon, ELIs from the bond. Catenation. So these two reasons, simple reasons, which is called as tetravalency and catenation, are together responsible for millions of carbon compounds. Are together responsible for millions of carbon compounds. Together responsible for millions of carbon compounds. Right, so this is what is called as the basics of organic chemistry and why even this is existing. So because of these two reasons. What next? So next is we talk about what is actually covalent bond. What I want to say with here is that carbon can form single oblique multiple bonds. This is what I want to talk to you here. That is, my carbon can form a single bond carbon. My carbon can form a double bond carbon. My carbon can form a triple bond carbon. And this can happen in multiplication also. Means can happen in multiplication also. I mean to say this that can happen in multiple what should I say, multiplication also, multiple location also, whatever, multiple positions in the molecule, that way it can also be said in the molecule. The little background noise as I hear, but okay. Example I want to say that's it could be 1 2 3 4, or say 1 2 3 4 with a double bond, or say 1 2 3 4 first bond double, third bond double, and it could happen in various combinations as well. Say, for example, it's gonna be carbon, triple bond carbon, and a single bond carbon, and then double bond carbon. Probable. Means carbon can form single, multiple bonds, can happen in multiple positions, can happen in any possible combination that is possible. Multiple combinations possible. Multiple combinations possible, and that is how this is gonna be working for us, right? Cool. So all these things we come across, but remember a quick note that you should make here. Note: carbon cannot exceed, carbon cannot form more than 4 bonds. Remember this. What do we say? Carbon cannot expand its octet. Now, anybody who can tell me its reason is beautiful. Even if you don't tell me, I will tell you for now, but remember it's really important. Carbon cannot expand its octet. Why? Because of absence of d orbitals. Because of absence of p orbitals. Now, what is this concept? So this is what we do in p block and chemical bonding also. That atomic number less than 10 concept. What is the concept behind? Sir, atomic number less than 10 less than 10, comma, no octet expansion possible. Right? And this is how we do it. And remember guys, one thing. When we say covalent bond, when we say carbon can form single multiple bonds, it could be with different atoms also. What I want to say is it could be with different atoms also. I should take it a little down because that is a concept which should not be confusing for now. What I wanted to mention here is multiple combinations possible, bonds also possible with different atoms. With different atoms as well, right? How do I want to say that? So the way I want to mention is, say carbon oxygen, carbon hydrogen, then I have carbon nitrogen, then I have carbon double bond oxygen, and multiple bonds like this, single with hydrogen, single with nitrogen, single with any atom, then carbon Br, any bond as such is true. Any bond as such is true. Okay, any bond as such is true. Got your point? So this is what is called as the bond that the carbon forms. In general, remember again, cannot, oh, I've written it twice, cannot form more than, carbon cannot form more than 4 bonds. This is carbon cannot form more than 4 bonds. Again, as it beautifully conveys in one word, the covalency of carbon is 4. Remember this statement. It's gonna be your objective question this time in NEET 24, that your covalency of carbon is equal to 4. Then this is important as well. Right, sir? Covalency of carbon is equal to 4. Till here, any person, any doubt, most welcome. Right? Because the next topic that I start with takes me to a deeper version of organic chemistry, which is called as types of bond cleavage. But before I start with this, just take a second to complete this so that we are through. I'll just quickly hide myself for a minute so that you can complete it in less than 1 minute. Quickly note it down, and then we start with the most important concept of something which is called as types of bond cleavage. Quick, 1 minute of time before we start this new topic. All right. So this part is noted, and we come to something which is the most important section now, called as types of bond cleavage. All right. So see, when I say types of bond cleavage, I always mean to say the way, or should I say that how the bond between two atoms break. Types of bond cleavage. So when I use this word bond cleavage, I want to say how the bond between two atoms break. So when I start this, that how do we break it? All of us should know just one thing, that any covalent bond is made up of two electrons. Remember, guys, this is the basis of your bond formation. Any bond will be formed by two electrons. Any relation will be between two people, one girlfriend, one boyfriend. Two boyfriends can also happen, but still not allowed. Or two girlfriends can also happen, still not allowed. But then any relationship will be with two people. Any bond will be two electrons, one from each atom. Say, for example, one from each atom. For example, if I have carbon, single bond carbon, it means that the single bond is nothing but are two electrons from each carbon. Two electrons total, one from each carbon, right? Bond is two electrons. Bond is two electrons. Right, sir? Bond is two electrons. Now, quickly to tell you here, guys, bond is two electrons. So, quickly to tell you here, types of bond breaking is of two types. Bond cleavage is of two types. One is called as homolytic bond cleavage, and the next one is called as heterolytic bond cleavage. Heterolytic bond cleavage. Quickly, if anybody knows this difference, I'll be more than happy to hear from you. Homolytic bond cleavage, heterolytic bond cleavage. Sir, when I say homolytic bond cleavage, it happens between two atoms. It happens between the atoms which have no oblique lesser difference in their electronegativity values, which have low oblique lesser difference in their electronegativity values. Now, this word which has come should be addressed right away here. The term PS electronegativity is defined as Anu Chaudhary says two watching, so don't expect answers in comment section. Anu, very good afternoon, very good evening. Sorry, it's already 5:03 on the clock. So very good evening. In case you are there in the chat box, I would reply. I would expect your reply also. Indeed, even a single person attending the class would be equally benefited. So that in case, okay, you have no answers to give, not a problem. But just keep on, in case you have any doubt, just quickly put on the chat box. That will be helpful. Since it's a live session going on, it will actually be a little more gaining for you also. But I understand these are very, very basic concepts and you should actually be very thorough with it. So in case you're doing it for the first time or you are revising it seriously, tune into the session for long till the end, to be honest, so that you get benefited a lot. I'll cover every minute detail, a little slow, a little fast, but everything required for you to start organic will be covered here. All right, good one. So now, electronegativity is defined as the tendency of the atom to keep the shared pair of electrons towards itself. To keep the shared pair of electrons towards itself. To keep the shared pair of electrons towards itself. Okay. Now, how do we say it? Towards the shared pair of electrons towards itself. And the order that I have with me is most common. That is your fluorine, oxygen, nitrogen equal to chlorine. And the way we pronounce it is called as phone call. We pronounce it as phone call. This order is actually Pauling scale that we do in periodic classification, class 11th, chapter 3. But this is enough. We will talk about here. Always remember fluorine is the most electronegative atom in your entire syllabus, in your entire chemistry. Right? Fluorine is the highest electronegative atom. Alright, fluorine is the highest electronegative atom. Good one, sir. So now homolytic bond, we come back to the concept. What we were talking about happens between the atoms which have no oblique lesser difference. It means, say for example, if I have one carbon and if I have the other carbon as well, okay, so if I have a carbon atom and another carbon atom. So since the two carbons have no difference in electronegativity as such, so this bond breaks in a homolytic fashion. When I say homolytic fashion, I am very clear about how it goes. So when I say homolytic, the bond breaks homolytic. The bond breaks homolytic means one electron goes to each side. Remember this. This is very, very, very important. When we say homolytic bond cleavage, in homolytic bond cleavage, we want to say in homolytic bond cleavage, in homolytic bond cleavage, comma, each side gets one electron. And remember, guys, the trick towards it is gonna be when we say one electron, it means each carbon gets back its electron itself. So, whatever I gave you for the bonding, whatever I gave you for the bonding, you gave me back. It was my electron and you gave me back. Remember, this is really, really, really important. My electron, you gave me back. Even the other carbon was also saying, said my electron, you also gave me back. Each carbon gets back its own electron, and therefore, carbon does not get any charge. This is very, very important in this phenomena. Does not get any charge in this phenomena. Why? Because, sir, because, why? Because, sir, because, why? Because, sir, because that electron was of that same carbon. So when I'm getting back my own electron, I will have no charge. So when I am getting my own electron back, I will have no charge, and that is where carbon does not get any charge in this phenomena, and what is formed is called as formation of C dot plus C dot. We call it as formation of free radical. Again I remember, again I repeat, sir, carbon gets no charge because the electron that carbon is getting belongs to itself. Therefore, no scope of charge, sir. Point number one. At the same time, since I'm getting my electron back, therefore it is called as formation of free radical. And when I say free radical, they are very reactive species. They are very reactive species. At the same time, a trick to remember, which will be discussed in the consecutive hours from today, is that the order of stability is nothing but 3 degree greater than 2 degree greater than 1 degree greater than methyl. This is most important. This is most important, that the order of stability of your free radical is 3 to 1 methyl. Yes, a trick to remember here, it is same as carbocation. What is that? We will talk about it. Carbocation. Even the order of carbocation stability will be 3 to 1 methyl. Same order. Right, sir? So they are very reactive species. C dot C dot are formed, homolytic, and these arrows, since they are half each, these special arrows are called as fish arrows. These arrows are called as fish arrows. These arrows are called as fish arrows. You see, it's gonna be a half arrow towards each atom because a bond had 2 electrons, one goes to each side, and that's it. One goes to each side, and that's it. All right, C dot C, and you form that. Quickly here, the second type of bond cleavage is heterolytic bond cleavage, and what we talk about, it happens when it happens between the atoms. It happens between the atoms which have difference in electronegativity. Difference in electronegativity. And if that is the case, if you and me have a difference, remember the electronegative atom takes away both the electrons. Takes away both the electrons, leaving positive charge on the carbon atom. Very, very important. Positive charge on the carbon atom. Leaving positive charge on the carbon atom is what we talk about when we come down here. We put the heading for heterolytic bond cleavage, heterolytic bond cleavage, right? And see, it's carbon with the electronegative element X. So there's a electronegativity, so I am towards X. So when this bond breaks, the bond breaks in a fashion that both the electrons goes to X, that both the electrons goes to X, and what you make it as C plus X minus. That is formation of anion and cation, formation of anion and cation, formation of anion and cation in the heterolytic cleavage process. In the heterolytic cleavage process. Formation of cation and anion in the heterolytic cleavage process. And here, sir, when I talk about cation, anion, positive, negative, the reason is obviously the difference in electronegativity values. Remember, carbon with a positive charge is called as carbocation. Carbon with a positive charge is called as carbocation. Very, 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 very important concept to remember. Heterolytic bond cleavage. Heterolytic bond cleavage happens in polar solvents. When I say polar, that is solvents like H2O, which has tendency to show polarity. Polarity again, electronegativity difference. Same word, same meaning, different words. Polarity. Polarity means dipole. Dipole means electronegativity. So heterolytic bond cleavage happens in polar solvents. Very, very important. Acids, bases, they're all polar solvents. Whereas when I say homolytic bond cleavage, it happens in organic solvents, happens in non-polar solvents, also happens in presence of sunlight, in presence of light, because you will have cases where this is happening in the presence of H nu. At times it will happen in the presence of UV light and so on. So in terms of light, you will have to happen this one. There are multiple cases. Example I will give you now. Sir, example we should know that, for example, if a methane molecule CH4 plus Cl2 in the presence of H nu happens, then this Cl2 H nu is a combination that will give you Cl dot plus Cl dot. There's this mechanism, free radical substitution in hydrocarbons chapter. Free radical. Where did this free radical come from? Sir, it has come from the types of bond cleavage. It has come from the types of bond cleavage. Cl dot plus Cl dot. Remember guys, Cl dot plus Cl dot, Cl2, and you get it as CH3Cl plus HCl. At times this reaction doesn't stop here. Then the CH3Cl reacts with Cl2H nu. You get it as CH2Cl2. Again you doesn't stop. Cl2H nu. You have CHCl3. You still don't stop. Cl2H nu. And you have CCl4. Very, very important. This is called as, sir, free radical substitution. You have this mechanism in your syllabus also, as I mentioned, chapter hydrocarbons, free radical substitution. We have two more hellos today in the chat box. One is Dr. Joshi, homeopathy, and Atikur Rahman. Dr. Joshi, hi, very good evening. If you're already a doctor, my wishes for you. Hope you're doing good. And then Atikur Rahman, hi guys, hi student. You will a little late. You are almost, I should say, 45 minutes or so. But in the session ahead is gonna be a lot learning experience. So let us be geared for it, right? So this is how the free radical substitution happens. And at the same time, we all know that if I'm talking about, say, if I'm talking about say CH3Br plus what should I say, CH3Br and then Na, not Na, I should say, plus KCN. Okay, so I will have CH3CN plus KBr. Why I want to show you this is that says CH3 carbon carbon carbon, and this is Br, and this is K plus and Cn minus. So we should know that this Cn minus replaces Br minus. Okay? Cn minus replaces Br minus. But I will obviously talk more about detail right away in next 10, 15, 20 minutes. Right? So this is called as substitution reaction. This was also called as free radical substitution reaction. Why free radical is always more important? Quick recap. So free radical stability is 3 to 1. Why I am telling you is this very important concept. Please take it, very very important concept to take. Say for example, if you have CH3, CH2, CH3 plus Cl2 in presence of light, or say H nu. Remember Cl2, CH3, CH2, CH3 is called as propane. In case somebody is very new to the chemistry, it is called as propane. And with Cl2, you have two options. One is that CH3, CH2, CH2Cl, and the other option is that CH3, CH, CH3 with chlorine attacking the second carbon. Chlorine had two options to attempt the rightmost carbon or the second carbon, the center carbon. So in that case, this will be my major product. This is gonna be my major product. Why? Because it is a 2 degree. It is a 2 degree alkyl halide. And then this is a 1 degree halide. So 2 degree is always more stable when it comes to free radical mechanism. Now, when we're talking about all these things, what is homolytic, heterolytic, carbocation? Let us take 1 minute of time and also talk about what is called as degree of compound. In very simple language, my dear friends, the carbon to which I am attached, note, the carbon atom to which I am attached, the carbon atom to which I am attached is itself attached, is itself attached to how many carbons? Remember, the carbon to which I am attached is itself attached to how many carbons? Example. Carbon 1, 2, 3, carbon, and then I am plus here. So what will be the degree of carbocation here? What is going to be the degree of cation? Sir, cation, positive charge. So the carbon at which this positive is present, the carbon at which this positive is present is directly connected, it itself attached to how many carbons directly. So how many carbons I am attached to it directly? 3. Therefore, it's gonna be a 3-degree carbocation. Similarly guys, this carbon, carbon, and this is a positive charge, say for example. Now, the carbon to which I am attached is directly attached to how many carbons? One on the left and one on the right. It's gonna be a 2-degree carbocation. Not 3 degrees, sir. It's gonna be a 2-degree carbocation. Why? Because we are talking about direct connection. We are concerned about direct connection. We are concerned about direct connection, right? Not direct, like indirectly. In that way, say for example, my 1 degree is called as primary. My 2 degree is called as secondary. My 3 degree is called as tertiary. 1 degree, 2 degree, 3 degree, primary, secondary, tertiary. Yes, the lesser than that is called as CH3 plus or say CH3 dot. It is called as methyl carbocation or say CH3 dot is called as methyl free radical, right? Methyl free radical CH3 dot. Quickly take a minute of time to note this because the next thing that I tell you about is something really important, and that is what is your attacking species. What are they? Right? Quickly. Attacking species, what are they? Is what we talk about. Take and complete. 1 minute of time and complete the notes. Quick. All right, so it's copied. All copied, sir? Yes, sir. All copied. Cool, let us start again. Now we talk about something very, very important. Types of attacking species. Right? Now, when we talk about attacking species, more or less we come across only two things. One which loves positive charge. What? Which loves positive charge. Or the second which loves negative charge. So there could be only two types of attacking species. Number one, which loves positive charge. Number two, which loves negative charge. So anybody which loves positive charge will be called as nucleophile, because phile means love, attraction, right? So tomorrow, if you go into the market and you say, I file momos, I file momos, I file chow mein, I file dosa. So obviously the shopkeeper will not understand and throw you out, but file would means I love, I attract these things. So nucleophile is something which loves positive charge, right? Nucleophile, positive loving, right? So anybody in the chat box, you can mention this file, and that would mean you love. Indirect way. Sir, today in my dinner party, I'll tell my parents. I file this person. Papa would say, file. Oh, you are filing a case against and he will not understand. You're talking about file. OMG. And then blame will come on me. No, 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 don't do it. Don't do it. Okay. Which loves negative charge? Quite obvious now. Called as electrophile. Beautiful statement. Nucleophile and electrophile. Negative loving. So now you see here, it's going to be very, very obvious. Very, very obvious the way we deal it now. It says, sir, I am a nucleophile. Right? Say, for example, I say you, I am a positive charge loving. Will mean two things, sir. Number one, either it is electron rich, or should we say what? Either it is electron rich. When we say electron rich, we say presence of lone pair. Then only I love you, na? Sir, if I have extra electrons, then only I will love a positive charge. So either I am electron rich, or the most obvious of the reasons, or I have a negative charge. Very obvious, sir. If it has a negative charge, then obviously it will have positive charge. Why? Because opposite charges attract. Why? Because opposite charges attract. Similar charges repel. Common language, opposite charges attract. Similar charges repel. So either it is electron rich or it has a negative charge. So in both the cases, guys, in both the cases, remember, example, remember, Say for example, Cl minus comes under the second banner, negative charge. Similarly, Br minus comes under second banner. Cn minus comes under second banner. F minus comes under second banner. OH minus comes under second banner. And so on. Very, very small examples. And you keep on getting that. It's just as an example, MnO4 minus comes in the second banner. It has a negative charge. So who will it always attract? Positive charge. Simple. MnO4 minus. Say for example, what should I say? SO4 2 minus. Grignard will come. MgBr plus alkyl minus. That is the scenario there. It is gonna be CH3 minus. Or say, I should say alkyl R minus. Na? I should say R minus. R minus. And where it is coming from? It is coming from Grignard reagent, sir. Right? And when I say these lone pair things are also nucleophile, the first example that I should always cite is gonna be ammonia. Sir, it has a lone pair of electrons and therefore lone pair of electrons makes it a nucleophile. Remember, lone pair of electron makes it a nucleophile. Lone pair of electron makes it a nucleophile. Okay. Done, sir. Lone pair makes it a nucleophile. And any such thing which you will see carrying lone pair in your syllabus can actually behave as your nucleophile because that extra pair of electrons is a negative charge and that will always attract a positive charge. This is very, very important when you talk about nucleophile. Very important. NEET has asked multiple times which of the following is an electrophile, which is a nucleophile, and so all these things. Right? So now, when it comes to electrophile, so now it is very, very clear. Electrophile, which loves negative charge. So obviously, either it is electron deficient. That is why it is loving negative charge, sir. And when I say electron deficient, the key word is electron. Yeah, we should say incomplete octet. We should say incomplete octet. And the second most obvious reason is that it has a positive charge. And when we say it has a positive charge, it is very, very evident that it will always will will attract negative. And when we say as an example to it, say NO2 plus, even Cl plus. Anything with a plus charge, say CH3 plus. They all with a plus charge are called as electrophiles. Alright, anything with a plus charge is called as electrophile, and with the incomplete octet per se, the best example is gonna be BF3, boron compounds. Boron is an example of incomplete octet. Example of incomplete octet. All right. Quickly pen it down, guys. Quickly. Quickly pen it down. Not a single moment to waste. Quickly pen it down. And we start it. How we do it forward. Quickly pen it down. Lone pair of electrons makes it. It was a very, very key difference what we talked about between electrophile and nucleophile. Electrophile, which loves electrons, so negative charge loving, therefore it has to be a positive charge. Done, sir? Done, sir. Right? This is your types of attacking species. Cool. Now, what is electron that I have taken in my context of the chapter is electron displacement effects. And then I merge few of them, put some questions in front of you, and then you are through it. Put the heading, the lengthiest and the most important. Hi, Janu. Oh, Janu Janamana. Okay. It's Janu Janamma. Okay. Hi, Janu Janamma. Very good evening, guy. Okay. Most important topic starting now. Electron displacement effect. Electron displacement effect. How do I take it up? Sir, the first one that we talk about here, we will not talk about everything here, but we will talk about something most crucial, most important, and the one which has real examples to play in my questions is inductive effect. Then it is resonance effect, and then this is hyperconjugation. And this is hyperconjugation. Okay. Inductive effect means the displacement of electrons. The displacement of electrons, or the easier and more technical word would be the polarization of electrons. The polarization of electrons towards more electronegative atom, towards more electronegative atoms, something which was called as, electronegativity effect and heterolytic bond cleavage. That is what we're coming to. The displacement of electrons towards more electronegative atom, creating delta positive and delta negative charges. So this is called as delta, and delta means called as partial. This is called as delta, which actually means partial. So delta positive and delta negative charges. We talk about each effect one on one. So let us not talk about resonance and hyperconjugation for now. Sir, inductive effect itself is of two types, which means plus I and minus I. Which means plus I and minus I. When I say plus I effect, I always mean to say electrons are pushed away from the atom. Pushed away from the atom. Take the keyword pushed away. from the atom. And when I say minus I say electrons are pulled towards the atom. Electrons are pulled towards the atom. And that is where minus I comes to more electronegative atom. As an example, if I talk about more electronegative atom, as an example, if I talk about it, sir, I mean to say that, say for example, if it is gonna be carbon, CH3, CH2, CH2, Cl. So remember, this carbon chlorine bond is something where it will start, it is gonna be delta negative, and then this subsequent will get as delta positive. Similarly, seeing that it's gonna be a delta delta positive, and that will decrease further. Very, very simple, sir. I will take a minute more to explain this. Sir, it's carbon, 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 say chlorine. Now, this carbon chlorine bond is always polar. We know that electrons are towards chlorine. So, chlorine gets a delta negative charge. And since this carbon gives away its electron, since this carbon gives away its electrons, since this carbon gives away its electrons, comma, since this carbon gives away its electrons, comma, it gets delta positive. This is just the concept I am trying to write for your better understanding. This carbon gets a delta positive. Now, seeing this positive charge, step by step we will say, sir, seeing this positive charge, electrons of the next bond get polarized. Electrons of the next bond gets polarized, and therefore this bond makes it electron shifts a little towards that and brings a smaller delta positive. Gets polarized, smaller positive on the next carbon, on the next carbon. Very, very important. And similarly it goes on. Similarly it goes on. Remember, guys, delta positive. Then similarly, this gets a little towards this one, delta positive. The beauty of this effect is it dies with distance. Please note it in the caps lock fashion. Inductive effect dies with distance. Inductive effect dies with distance. Inductive effect dies with distance. Right? Inductive effect dies with distance. Okay? Inductive effect dies with distance. Now, what happens next? Remember, carbon negative and positive and all those things are happening. This is okay. With distance, it dies. So when we talk about minus I effect, I come back to again here plus I and minus I. Okay, first quickly note this concept down in case you haven't. Quickly, less than 30 seconds, note it down. Less than 30 seconds, note it down quick. Quick, quick, quick. Noted, sir? All done? Quick. Right, sir. All done, sir. Good one. Carbon positive. Now again I come back to plus I minus I that I was talking about. So when I say plus I effect, the best example is gonna be all alkyl groups are plus I in nature. And when I say plus I means, and when I say plus I, it means that they give electrons, they push electrons away from themselves. I'll give you an example also. They push electrons away from themselves. Sir, example CH3, CH2, CH3 and say dot, and this carbon has a plus charge. At the same time, an example CH2 dot, and this has a methyl group. Sir, here, I am asking you for the stability. This is my first question, and this is my second part. Which is more stable? Remember, guys, any alkyl group, is a plus I group. Answer: alkyl groups are plus I. Alkyl groups are plus I, which means alkyl groups are plus I, which means it will push electrons. It will push electrons. It will push electrons. It will push electrons. And when it push electrons, comma, therefore stabilizing the positive charge. Therefore stabilizing the positive charge. Therefore stabilizing the positive charge. Similarly here, it pushes the electron towards itself, away from itself, electron. So here also it gets stabilized, but left side there are two plus I groups. In left side on LHS, comma, there are two numbers of plus I groups. Therefore, positive charge is more stable. Positive charge is more stable. Implies when I talk about stability, implies if I talk about stability, comma, my 1 has to be greater than 2. If I talk about stability, my 1 has to be greater than 2. Again, quickly, it has 2 plus I groups, it has 2 plus I groups, and it has just 1 plus I group. just 1 plus I group. Alright, just 1 plus I group. Is it all done? Sorted, sir? Clear? Right. Stability. I'll give you one more example here. One more example so that we take it more properly. Sir, question. Say for example, sir, CH3COOH and CH2ClCOOH. Which is more acidic? Which is more acidic? Question. Which is more acidic? Question. Quickly try. Give a second and try, sir. This is gonna be my first part. This is gonna be my second part. Which will be more acidic? A good term which is called as how do you define acidity, how do you define the acidic strength, and you get the concept also right away along with you. You get the concept right away along with you. Quickly, which is more acidic? Quick, 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 quick. Right, sir? So quickly we will note a point which is most important, sir, for your organic chemistry. And then notice to check the acidic strength, to check the strength of the acid, to check the strength of the acid, comma, remove hydrogen as H plus, remove hydrogen as H plus, and then and then and then check for the stability of the anion, and then check for the stability of the anion. Means molecule minus H, molecule minus H plus, that anion whatever it is formed, that anion whatever it is formed, if it is stable, then it is a strong acid. Sir, after the loss of H plus, if you are stable, then obviously you are a strong acid. Yes, if it is not stable, you are a weak acid. Wow. So you remove the H plus and then study the anion. For example, in this case, CH3COOH and CH3CH2. So in this case, sir, CH3COOH and CH2ClCOOH. What do I do? Sir, I do it as CH2, not CH2, sorry, CH3COO minus. This is the anion. And then this is CH2ClCOO minus. Now the CH3CH2 group is common. Here my Cl is electron withdrawing group. How do I know it? Electron withdrawing group, which is minus I. Electron withdrawing group, which is minus I. Did I mention it somewhere? Plus I examples I have mentioned, minus I examples I have not mentioned. Okay. Minus I. Cl is an electron withdrawing group because of its high electronegativity. Because of its high electronegativity. Because of its high electronegativity. CH2Cl, CO minus, CO minus. So when if it is electron withdrawing group, so it takes electron, it drinks electron, it drinks electron, it gains electron. So if it gains electron, therefore this minus charge is stable. Implies negative charge is stabilized. Negative charge is stabilized. And if that is the scenario, negative charge is stabilized. If that is the scenario, comma, always, if negative charge is stabilized, it means this is a stronger acid. B is a stronger acid than A. B is a stronger acid than A. So this is how you check for the acidic strength before. Okay, quickly pen it down first in 1 minute of time. Quickly pen it down. And this is how you compare the acid support, the strength of the acid, and then you do it. Quickly note it down. How do we compare the strength of the acid? All right. So all noted, sir. All noted, sir. B is done. A is done. Right. So now quickly one round of question. Example. Carbon with a positive charge 1, 2 and 3. CH3, CH3, CH3. Then carbon H with a positive charge CH3 and then CH3. Then carbon with two positive charges and then a single CH3. What is the order of stability? What is the order of stability? Click, 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 click. What is the order of stability? Quick, quick, quick. Order of stability. Very quick. Do it. Very quick. Order of. Now it's very, very obvious also, guys. We've done it 2, 3 times now. So there are three plus I groups, three numbers of plus I groups, three numbers of plus I groups. Here it is only two numbers of plus I groups. Here it's only one number. More the plus I, more is the positive charge stabilized. Again, more the number of plus I groups, more the number of plus I groups, comma, more the number of plus I groups, comma, more stabilized is the positive charge. More the number of plus I groups, more stabilized is the positive charge. And again, if you see it very carefully, you realize that this was a 3-degree carbocation, this was a 2-degree carbocation, and this was a 1-degree carbocation. And you summarize that the stability order of carbocation is nothing but 3 degree greater than 2 degree greater than 1 degree greater than methyl. Three degree, 2 degree, 1 degree, and methyl. 3 degree, 2 degree, 1 degree, and methyl. Stability order of carbocation. Right? Quickly, let us take it as one more example, which will help me concept understand a little more. Example is same question with a negative charge. Then you have CH3, CH2 minus. Then we have CH2, not CH2 per se. We have CH minus with CH3 and then CH3. And then we have carbon minus and then 3 groups attached to it, CH3, CH3 and CH3. That way. So now I have, right? So now I have this question with all 4 as negative. Quickly guess the answer and we do it now. Quickly, 30 seconds of time and do it. 30 seconds of time and we do it. Quick. I have 4, but all 4 are now anions. All 4 are now anions. Quick, quick, quick. Role will be same, sir. This is gonna be plus I, plus I, plus I. And when I say plus I groups will destabilize the negative charge. Why? Because it will increase the electron density. Why? Because it will increase the electron density. And if it increases the electron density, then it is reversing the order, sir. Means this is gonna be most stable. Order of stability will gonna be from the left, that is 1 greater than 2 greater than 3 and then greater than 4, and that is what you call it as order of stability of carb anion. Order of stability of carb anion is 1 degree greater than 2 degree greater than 3 degree and so on. Remember, it's exactly opposite of carbocation. Carbocation. So that is how this function is working, sir. Inductive effect plus I minus I and their relation plus I minus I, and how do they affect the positive charge. Just 1 minute. And how do they affect the positive charge, right? Okay. Now, one more statement, sir. One more question and one more statement also. Question here is, sir, CH3NH2 versus CH3NH3, which is a stronger base? Which is a stronger base? Which is a stronger base? Again, N has a lone pair, N has a lone pair. Anybody who doesn't know about it, this is also a really important concept, sir. When I say stronger base, basic strength is defined as, can be defined by the ease with which, basic strength can be defined by the ease with which a molecule can give its lone pair. A molecule can give its lone pair. So then how do we do it, sir? In this scenario, this is gonna be plus I. Alkyls are plus I. Alkyls are plus I. This is gonna be plus I. This is gonna be plus I. Plus I and plus I. 2 plus I means electron density on nitrogen increased. Electron density on nitrogen increased. And then here it's plus I. Here also it is increased. Electron density on nitrogen increased. Nitrogen increased. Right? Electron density of nitrogen increased. Here it is increased by 2, and therefore 2 is a stronger base, is a stronger base than 1. Why? Because 2 has 2 plus I groups, whereas 1 has 1 plus I group. Alright, plus I group. Sorted, sir? Clear? This much is clear to us. I hope rather very clear, but I hope a little is okay. So this is how you define plus I group and minus I group. Yes, there is order to it, which is a strong minus I, strong plus I. We have this in 11th NCERT captured. We will see it when we go to the text. Presently, we are just going through the concepts and how do they function. Right? As an example, sir, as an example, there are two benzenes, one with the chlorine and other with the NO2. Okay, one with the chlorine and the other with NO2. Question here is plus Cl2 in the presence of FeCl3 plus Cl2 in the presence of FeCl3. What does this reagent do? I'll give you a hint, sir. Cl2 in presence of FeCl3 will produce Cl plus, and anything with a plus charge is called as electrophile, which attacks benzene ring, which attacks benzene ring, which attacks benzene ring as an electrophile, right? As an electrophile. Not a problem, sir. Absolutely not a problem. What it is saying is, in this is case number 1 and this is 2, this is 1 and then this is 2, where the reaction, compare the rate of reaction. Compare the rate of the reaction. Compare the rate of the reaction, sir. So here, what do you say, sir? That Cl is a minus I group, and minus I group will take electrons. Will take electrons. NO2 is a stronger minus I group. Is a stronger minus I group. Answer anything which is minus I will take away the electrons. Remember, NO2 is strongest minus I group, which deactivates the benzene ring. Means it will absorb, it will take away so many electrons towards itself that benzene ring will get short of it. Benzene ring will get short of the electron, sir. This is how it's gonna be. In short, NO2 is stronger minus I, which deactivates the benzene ring for further electrophilic substitution. Very important, very important for further electrophilic substitution. And therefore, in this case, reaction in 1 will be faster. Rate of reaction in 1 will be faster than, will be 1, and they will be faster than 2. Rate of reaction in 1 will be faster than 2. Now, how it goes, sir? Rate in 1 is faster than 2. Why? Because in Cl it will be lesser deactivated compared to NO2. Means benzene in case of Cl will be lesser deactivated compared to NO2. Right, sir? Compared to NO2. Quickly pen it down, an important concept, and take a note of it. Very important. A question to come from it in NEET for sure. That concept itself is marvelous, covered in class 11th and 12th. Quickly pen it down. Quick, pen it down. Anu Chaudhary, is there in the chat box for now? Anu Chaudhary is there in the chat box for now? All right. So this is how the inductive effect section gets covered in general. Right, sir? Done, sir? Covered? Sure. Copied. We come to the next concept, electron displacement, which is called as resonance effect. See, we need to view resonance through two angles. One, resonance as a phenomenon, and two, resonance as its implication in our concepts. Right? Sir, when a single structure cannot explain, when a single structure cannot explain all the properties of the molecule, when a single structure cannot explain all the properties of the molecule, comma, multiple structures are required, multiple structures are drawn, multiple structures are drawn, full stop. They all are canonical structures. They are called canonical structures. Canonical structures. And the actual is called as and the actual is called as resonance hybrid. And the actual is called as resonance hybrid. And the actual is called as resonance hybrid. This phenomena is called as resonance. This phenomena is called as resonance. This phenomena is called as resonance. Means when a single structure cannot explain. As an example, I will tell you, sir. As an example, I will tell you, sir. When we are in class 11th, the definition of resonance comes from chemical bonding. When we are in class 11th, the definition of resonance comes from chemical bonding. Right? Example. Resonance example. So this is benzene. 1, 2, and 3. And also, this is benzene. Both are benzenes or not? Both are benzenes. Now, both represent benzene. Both represent benzene. Now, the shift of this can also be shown by some molecules. Point: a single structure cannot explain all the properties of the molecule. Is this phenomena? What does it call for? A single structure cannot explain the properties. Single structure cannot explain the properties. Right, sir? Single structure cannot explain the properties. In that scenario, the structures that we draw are called as canonical structures, and this is called as the resonance hybrid. This is the actual structure and is called as resonance hybrid. Right, actual structure called as resonance hybrid. Sorted, sir. All done. Clear? Very good. As an example, one more example. When we talk about carbonate per se, carbonate ion, which is CO3 2 minus, it is carbon, double bond O minus, O minus. Right? Carbon double bond O minus, O minus. Similarly, it could be carbon single bond O minus with double bond O with this O and single bond O minus. Or parallelly, it could be carbon single bond O minus, single bond O minus, and double bond O. So see, multiple structures are drawn to explain the properties. Why? What do we want to show here is that each bond could be a double bond, sir. Each bond could be a double bond. So eventually, what would be happening there is that there are three oxygen atoms. Overall charge is 2 minus, and the double bond is actually fluctuating between the oxygen atoms. Double bond is actually fluctuating between the two oxygen atoms. And this is where you get it as resonance hybrid. This is where you get it as resonance hybrid. So again, as the phenomena once we talk about, sir, when my single structure cannot explain all the properties of the molecule, then we have to draw some other structure to explain it, which contribute to the resonance hybrid, but then are different from it also. And the actual molecule is called as resonance hybrid. Quick 2 points to take, sir. In between resonating structures, in between resonating structures, comma, in between resonating structures, comma, in between resonating structures, comma, this type of arrow is used. Arrow is used. And while writing the resonance hybrid, right, resonance hybrid. And while writing the resonance hybrid, draw 1, 2, 3. 1, 2, 3 arrow. 1, 2, 3 lines. Right, sir? One more example. Sir, if I talk about, say, phenol, I have to make, okay, only benzene I will talk about. So, sir, how is this taken care? See here, benzene in actual is, I'll make a bigger one benzene for you for now. Good one, sir. Right, sir. This is benzene, a little more, sophisticated benzene, I should say. Right, sir. How do I say, sir? It is a combination of alternate pi bonds. Alternate pi bonds. Or a more beautiful definition of it could be, or a more beautiful definition of it could be pi electrons separated by a single bond. See, this is gonna be your golden statement. This is gonna be your golden statement. This is gonna be your golden statement that the pi electrons separated by a single bond. You see here what are pi electrons? Pi electrons could be, say, multi-electron bond, electrons in double or triple bond, or we should say pi bond and lone pair as well. So pi electrons are pi bond electrons or lone pair of electrons. Please, I am again saying it's a golden statement to solve these questions. Golden statement. And how do we deal it now? It is, sir, that your bond makes negative, negative makes bond. How do I see it? Sir, my bond makes negative and negative makes a bond. This bond will break at this point. It is just an explanation to the process, nothing else. It will be negative here, and let me just do one thing for your first reaction. Let me copy this benzene at multiple locations, as this will help you understand concepts better. Okay. 3, we should get 2 more. 4 and 5. Right, just 1 minute. Copy it first. 5 benzenes. Copied all 5 questions. Copied all 5. This one is copied. Okay, now, sir, what I was talking about is rule number one. Uh, 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 rule number one: bond makes negative, negative makes a bond. Rule one: bond makes negative, Negative makes the bond. Bond makes negative, negative makes the bond. How it goes is, please focus clearly. So this bond, this bond, what is it? It comes to this point. It wants to break at this location. So when it wants to break at this location, this bond wants to break at this location. Oh, this is an image captured, yeah. Shit. Wait, just give me 1 minute. Cut. Hey. Oh, failure concept there. No. Wait, it is not good. It is gonna be wrong then. No, cut. It should not be taken itself. Cut. Let us remove it then. Not a problem, sir. We'll make it. Right? Sir, it gonna be bond makes negative and negative makes a bond. So what happens here? Only this first time it is taking a lot of time because I want it to be a little more clear, I should say. Fantastic. So these two bonds remain unchanged. These two bonds remain unchanged. And this bond that breaks brings a positive charge and a negative charge. The other two bonds remain unchanged, and the arrow that has to be taken is double-sided arrow like this. The two bonds, that other bonds remain unchanged. I have mentioned here bond makes negative, negative makes the bond. Only one bond plays at a time. Only one bond plays at a time. Only one bond. Alright, quickly. So this negative will now make a bond. So now when this negative wants to make a bond here, this carbon gets 5 bonds. When negative wants to make a bond here, this carbon gets 5 bonds. In that scenario, this carbon has to break its bond. Remember, these are the structures being drawn only to explain that benzene shows resonance. Only to explain, nothing else. They have no existence also. They are called as canonical structure. As an example, quickly, third structure, once we make it, will give you a little more clarity quickly. Right? So now this bond, this positive still remains there. This bond still remains there unchanged. This is gonna be a new bond formed. So the bond negative makes bond, bond makes negative. And then similarly, now this next step, this negative will make a bond here, and this bond will make a negative here. So what is going to be the next structure? Now it's going to be very much self-explanatory. Negative makes a bond, bond makes a negative, negative makes a bond, bond makes a negative, negative makes a bond, bond makes a negative, negative makes a bond, bond makes a negative. Now this bond itself has not changed. This is not gonna change. It is stabilized now. Even this has been formed as a new bond. No change. Now this bond makes negative, and then this is already a plus charge. And now this plus minus makes the bond. And the last structure, let me draw it slowly, only slow, smaller, whatever. And then you get 1, 2, 3. Single directional arrows, bidirectional arrows in between both all the structures. Remember, guys, again, a quick 1 minute recap. Bond makes negative, negative. Okay, first you do one thing. First you copy it. That is helpful. First copy this one. Export gamers as something you were a word to say, but esport gamers. Okay, maybe. But sir, I'm really sorry. I don't know the meaning of the word that you mentioned. I'm really sorry for it, but I don't know the meaning. Right? Done. So what you actually see is nothing but just the position change of the double bonds. Alright. So what we see is nothing but the change in positions of double bond. Eventually the difference between the two, see this is the starting and this is the ending. You see here the difference between the two is in the position of double bond. Is in the position of double bond. That's it. And all the structures drawn are called as canonical structures. Ashank Srivastav says hello. Hello, Ashank. Means what I want to say here is that all the structures drawn are called as canonical structures. Right? And the actual structure is called as resonance hybrid. Actual structure is called as resonance hybrid. Actual structure is called as resonance hybrid. This is called as electron ring of the benzene molecule. Remember, benzene molecule is an aromatic compound which we will discuss in maybe some sessions to come from. This is called as electron ring, and that makes it very, very stable molecule benzene. Right? Aromaticity and all those things also comes into the discussion. Right? Resonance hybrid. So this is the basic concept, that is resonance, wherein a single structure cannot explain all the properties, and therefore we have to go to the multiple structure concept. Now we talk about types of resonance. Types of resonance. And we have to talk about two phenomena here. One is plus R, the other one is minus R. One is plus R and the other one is minus R. So plus R is when the atom, or should we say when the atom or molecule, whatever, when the atom or molecule gives away, same as inductive, sir, same as inductive, gives away the electron, gives away the electrons, that is, pushes away from itself, pushes away from itself. This is called as plus R effect. Also, in minus R, it is when the atom or group of atom or molecule, when the atom oblique molecule pulls, that is gains the electrons, oblique pulls the electron pair towards itself. Very, very important. Very, 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 very important. Pulls the electrons towards itself. So in plus R case, you have to note it down that for this, the atom attached to benzene ring, the atom attached to benzene ring, the atom attached to benzene ring should have lone pair of electrons. Should have lone pair of electrons. Sir, requirement is very, very clear. Requirement is very, very clear. Lone pair of electrons. That's it. You have it and you are through. You have lone pair of electrons, you will be plus R group. You have lone pair of electrons, you are plus R group. That's it. Again, note for the second thing, note to show minus R effect, comma, the atom attached to benzene ring, the atom attached to benzene ring should not have lone pair, should not have lone pair, but should have a pi bond, should have a pi bond. This is gonna be your 5-star golden rules to know when and what will be the role of resonance. Very, very important. As an example, my benzene with a NH2 molecule with a lone pair will be a plus R structure. Parallelly, my benzene with a OH on it with a lone pair of O will actually be a case of plus R effect. Similarly, okay, let us name also some, because this is aniline. Some molecules let us name. Then this is phenol. Similarly, my benzene with the OCH3 with O as a lone pair named as anisole is a case of plus R effect. Similarly, my benzene with a Cl on it with a lone pair is a case of plus R effect. So any group of atom attached on the benzene, the only mandatory condition is lone pair of electrons. Presence of lone pair of electrons. That's it. You are there, you are through. Presence of lone pair of electrons. You are there, you are through. Remember, you are there, you are through. That's it. Right, sir? Sorted. This is all done. Plus R minus R, we are on examples. Okay, this is the plus R examples. Second example, other examples here. Also, benzene with aldehyde on the top, named as benzaldehyde. Benzene with an aldehyde is called as benzaldehyde. Benzaldehyde. Carbon has no lone pair, but has pi bond. Carbon has lone pair, but has pi bond. Therefore, shows minus R effect. Very important statements. Each one has a business application. We will talk about it. Entertaining video says, sir, doubt. Please put the doubt, sir. I'll be more than happy to answer it. But if a doubt is a doubt, then I have no doubt that your doubt is not a doubt, and therefore your doubt has no answer to me. So if you have a doubt, you put the doubt. In case your doubt is a doubt, then I have no doubt that your doubt is not a doubt. Smart. Yes. Smartness overloaded. Okay, not a problem, sir. Alright, sir. Benzaldehyde minus R. Similarly, there's a second name to another molecule which is called as benzene with a C double bond O CH3. The name is called as, we will discuss about it in detail, acetophenone. Acetophenone. And whenever it is acetophenone, again carbon, same structure, same thing. Carbon has no lone pair but has pi bond. Okay, there's a question that that a student has, is what is benzene? Well, this is a pretty difficult question for me to answer. But okay, let me try, sir, in case I am able to handle your doubt. Sir, benzene is nothing but benzene is C6H6, which means when we draw the structure, so benzene is a hexagon with alternate double bonds, and each carbon has a hydrogen attached. Each carbon has a hydrogen attached. Okay. So whenever we delete this hydrogen and we put say chloro, then it becomes a chlorobenzene, and so the namings are done. The structure that remains is called as phenyl ring, and that is how benzene and the rings are named. Right, sir? I hope I am able to at least satisfy some of your doubt, in case I am not so sure whether it is done for you or not, but that is how the benzene is. Right, sir? Yes, sir. Okay. No lone pair but has pi bond. Therefore, shows, therefore, shows, therefore, shows minus R. Minus R effect. Correct, sir? Correct, sir? Yes, sir. Yes, sir. Done, sir? Yes, sir. Okay. So now plus R, that lone pair is present, minus R, lone pair is not present. Let us see the resonance for a plus R group. Let us see resonance for a plus R group that will unfold total 4 answers. That is resonance for a plus R group. Resonance for a plus R group. How do we do it? It is benzene with the OH example. So O has a lone pair. Now again, this is also something which needs to be shown in a little bigger way. Let me quickly just in a smaller, quicker fashion, let me do it. One, wait. Just give me a second's time, sir. And you also make total 6 benzenes. Only the hexagons you make that will be helpful for you. Alright, let us keep it limited to these three only and we will take up. Right? So the first one is a normal benzene structure. This is gonna be this bond, then this bond, then this bond, and then OH. I am talking about phenol. So what happens is the only 2 minutes that you have to understand very, very kindly. You know what would I say? Very, very silently. Understand, sir. This O has a lone pair of electrons, okay? O has a lone pair of electrons which wants to make a bond with the benzene ring. O has the lone pair of electron which wants to make a bond with the benzene ring. Effect, this bond gets double bond O. H still remains there. Since O has given a lone pair, O gets a positive charge. Since O has given a lone pair, O gets a positive charge. No change in this bond. No change in this bond. However, with this double bond, the number of bonds for this carbon becomes 5. The number of bonds for this carbon becomes 5, which is not allowed. And therefore, this bond breaks to this side. And you get a negative charge. Bond makes negative, negative makes bond. We come to the same phenomena that we started in benzene. Bond makes negative, negative makes bond. Bond makes negative, negative makes bond. Now, how do we do it? How do we do it, sir? Bond makes negative. Similarly, now negative makes a bond, bond makes a negative. Now the structure above absolutely remains the same. OH plus. This new bond is bond. Then this gets a negative charge. This gets here. And so on. Similarly, now what is the arrow between the two structures? It's gonna be a bidirectional arrow. Bidirectional arrow. Right? Now again, negative makes bond, bond makes negative. Negative makes bond, and bond makes negative. So what is gonna be my fourth structure? Quickly let us do it. Quickly let us do it. So what is that? Double bond OH still remains above. Wait. Now you can note it down. Double bond OH still remains above with a positive charge. Then this bond is still there, no change. This is formed. Then this gets a negative charge. And last but not the least, this negative will make this bond, and bond will again go up, resuming to the natural number where we started with. Is that good one, sir? Is that your bond, 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 single bond OH with the lone pair? Again, the difference that you have to observe is only in your, again the difference that you have to observe is only in your position of double bond. The only difference, the only difference is in the position of double bond. The only difference is in the position of double bond. The only difference is in the position of double bond. Right? Only difference is in the position of double bond. Right, sir? Right, sir? Okay, take 1 minute of time more and copy this resonance very carefully. No problem, not a problem. Take 1 minute of time, rather more than one if required, but copy this resonance very carefully. Very carefully. Right, sir. All copied, all done, good one. All copied, all done, good one. Right, sir. Quickly now, two important concepts before we conclude something in terms of what is most important. Right? Sir, note. Very important. Sir, any atom. Oh, okay. Any atom attached to benzene is called as key atom. Only for resemblance, nothing else, just for a definition sort of thing. Atom directly attached to benzene. Atom directly attached to benzene is called as key atom. Okay, is called as key atom. Point number one. Point number two is called as key atom. This is the first thing. Okay, sir. Sir, the position just next to it, the position just next to it is called as ortho. Is called as ortho. Important. Position immediate next to key atom. Immediate next to key atom will be called as ortho. Will be called as ortho. Similarly, the next position to ortho is called as meta. Is called as meta. Meta. And last but not the least, the third position here is called as para. Para position. Ortho position, meta position, para position. So para is my farthest neighbor. Basically, it is a long distance relationship, diagonally opposite. Diagonally opposite. Right? Para is a position sort of thing which is diagonally opposite. Right? And all these are, you know, uh, names in terms of only benzene. It will not be taken in heptagon or more than hexagon. No. It's only for the benzene cases that we are referring to these positions as ortho, meta, and para. Short form O, M, and P. Short forms also O, M, and P. Okay, O, M, and P. Sir, how do I do it now? Quick two things to be taken care. In case of plus R effect, in case of plus R effect, comma. I am now minimizing it because I will be taking its screenshot to be taken there down again. Okay. Copy. I'm taking it down and I'll paste it as a very small thing there and it's here. Alright. Sir, a little better, okay? This much is okay. Sir, in case of plus R effect, comma, there is an increased electron density. Please mark these words. There is increased electron density at ortho and para positions. So when I say it happens this way, what does it mean? Sir, it means increased electron density at ortho and para positions. It's a key line written in the NCERT, and I am taking it as negative charge comes. Negative charge is an indication of it. Okay, is an indication of it. Negative charge is an indication of it. There is increased electron density at ortho and para positions. All right. Increased electron density at ortho and para positions. Most important. Which means electrophile. What is electrophile? Sir, electron loving species will attack at ortho and para positions only. At para position only. Why? Sir, I have two locations, one with a negative charge and one with no charge. Beta has no charge, right? One with a negative charge or one which has no charge. And I love negative charge. So where will I go? So where will I go? I'll go to negative charge. That is what it talks about, sir. One with a negative charge and one with no charge. So it will always go to the position with a negative charge. Right? Fine. I'm leaving some space and I'll come back to it a little later. I want to show you resonance in case of plus R effect. Resonance in case of minus R effect. Minus R group or minus R effect. In that scenario, quickly, another 5 benzenes to be drawn. Quick, let us do it. But now I'll copy. No more drawings, please. Alright, sir. 5 benzenes, quick. We are going minus R now. The first structure, obviously the main structure that we have, is an example of benzaldehyde, benzene, and all three double bonds in place as we have been doing it. Right, sir? Now, in this case, benzaldehyde is a minus R group. CHO has no lone pair, no lone pair. So it takes electron from benzene. So it takes electrons from benzene. It takes electron from benzene. See, the flow of electron is going to be exactly opposite. In plus R, the electrons were coming to benzene. Now they will go away from benzene, which means the electron will go towards this. Carbons exceeded. So for this, we need a double bond here, which we are asking a pi bond. No change in this. No change in this. but this carbon gets a positive charge because of the going away of the electrons. Now the above becomes two double bonds, then H no change, O with a minus. O with a minus. Then third structure, the bond comes to silent this positive charge. So this bond is formed. This bond has no change, and this is goes, so this is a plus charge. Above no change, carbon double bond O minus. Double bond is still there, no change. Then again, this bond shifts to satisfy this plus charge. You get it as no, this bond is already formed. There's a new bond that's formed now. And then you see here's a plus charge. Above there is no change, double bond carbon HO minus. Then this bond shifts downwards to satisfy this positive charge. So this is here, and this is here, and the same structure comes back. That is carbon, single bond H, double bond O. Between all the resonating structures, never miss to put a double-sided arrow. Never miss to put a double-sided arrow. Never miss to put a double-sided arrow. Right, sir? Quickly let us copy. No doubt. 2 minutes. Let us carefully copy with no mistakes to be done. There's no chance of a mistake to be done, sir. Resonance, we people have to be perfect. Resonance is something which is bound to give us 10, 12 marks in my NEET exam. Indirectly, obviously, they will not ask direct resonance. Moving forward in detailing, you will have how to study this one. Uh, Order of the stability of resonating structures. All those things you will also do. So quickly, quickly let us copy. Quick, 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 carefully. Any doubt you ask me in the chat box, not a problem, sir. Sorted? Let us continue, sir. Alright, let us continue. And again realize that, sir, in this section, what we have written, the charge still remains on ortho and para only. The charge still remains on ortho and para only. Coming back to my previous page here. Sir, in case of plus R effect, there is increased electron density at ortho and para positions. Means, if we say now minus I, a minus R, so we have to write that in case of minus R effect, comma, there is decreased electron density. There is decreased electron density at ortho and para positions. What does it mean, sir? What does it mean, sir? Ortho and para positions. What does it mean, sir? Sir, positive charge is an indication. Sir, the problem now is that the ortho and para has a positive charge. Ortho and para has a positive charge. Now what to do? Where will the electrophile attack? means means which means that electrophile which means that the electrophile which means that the electrophile will attack meta position will attack meta position. Why? Because ortho and para gets a positive charge and same charges repel each other. Why? Because ortho and para has a positive charge. Because ortho and para have a positive charge. And therefore, and therefore, you have to know that in case of electrophilic substitution reaction, the summary for this last 15-20 minutes, that is, in case of electrophilic substitution reaction, comma, in case of electrophilic substitution reaction, comma, plus R with the presence of plus R group, we should not say that way. In case of electrophilic substitution reaction, comma, the presence of plus R group, the presence of plus R group increases the electron density at ortho and para position, whereas in case of minus R group, in case of minus R, comma, it decreases the electron density, at ortho and para positions. Sir, the word is very, very clear. Very, very clear. If I am a plus R group, the word is very clear. Plus R group, then electrophilic substitution takes place at OP position. Simple. Electrophilic substitution takes place at ortho and para position. Now, where do we see this? Yes, minus R group, comma, electrophilic substitution reaction. Electrophilic substitution reaction takes place at meta position. And do you see a very, very common phenomena that in case of plus R, ortho and para position, it's happiness. Wow, increased electron density, electrophile would love to attack. Yes, yes, yes. More electrons I want to attack because I am electrophile. Yes, yes, yes. More electrons I want to attack because I am electrophile. But electrophile, positive, positive. No, sir. Now the only option that it has is minus R group has a meta. And what should we say? It is the only option available. The only option is meta, as ortho and para as OP positions have positive charge. So do you realize that in case of plus R, ortho para is my happiness, whereas in case of minus R, meta is my compromise. Meta is my compromise. So that is how you summarize plus R and minus R in case of benzene. So now the point is not that. The point here is, what is the application? Sir, application last next 10 minutes. You understand each and everything and we'll be through this session. In class 12, my first chapter is gonna be haloarenes. I'll take you one by one, sir. My first chapter is gonna be haloarenes. Now, in case of haloarenes, it's gonna be Cl, and then I do anything. Say conc HNO3, conc H2SO4, conc HNO3, conc H2SO4. Only for your sum, only for your information. Conc HNO3, conc H2SO4 is called as your nitration mixture. Is called as your nitration mixture. Means it supplies NO2 plus. It supplies NO2 plus. Now NO2 plus is an electrophile. Wow. NO2 plus is an electrophile. And when it is an electrophile, it is going to attack ortho and para. Why? Because haloarenes, it has a lone pair, it is a plus R effect. So plus R effect means ortho para substitution, means it's gonna be ortho and para. Ortho and para. Quickly, its name's gonna be ortho nitrochlorobenzene, or say 2-nitrochlorobenzene. Similarly, 4-nitrochlorobenzene, easily called as O-nitrochlorobenzene. And that is how your ortho para plays a quick role. A quick role to play. Alright, a quick role. Similarly, this is one thing. Sir, reagent number 2. My CH3Cl in presence of anhydrous AlCl3. Quick reactions in presence of anhydrous AlCl3. So this is actually called as Friedel-Crafts reagent. This is actually called as Friedel-Crafts reagent. And when I say Friedel-Crafts, I always mean to say CH3 in presence of anhydrous AlCl3 is what I want to talk about. It gives you CH3 plus, forms CH3 plus AlCl4 minus. Here in this reaction, AlCl3 acts as a Lewis acid. Acts as a Lewis acid. And who is a Lewis acid? Which can actually accept a pair of electrons. What is a Lewis acid? Can accept a pair of electrons. Can accept can accept a pair of electrons. So this CH3 plus is an electrophile. It is an electrophile that attacks the benzene ring. Electrophile that attacks the benzene ring. That attacks the benzene ring. And when it attacks the benzene ring, I mean to say that now when I'm putting that in chlorobenzene, now when I'm putting that in chlorobenzene, what? CH3Cl in the presence of anhydrous AlCl3, I get it as Cl with the CH3 plus Cl with CH3 on the para position. 2-methyl chlorobenzene, 4-methyl chlorobenzene. Right? This is how your plus R effect gives you quick answers. You know it's plus R, so it's going to be orthopara. Plus R, it's going to be orthopara. One more example. So third reagent, because since we're dealing with the reagents, few of them I'll tell you. Third reagent is again CH3COCl in the presence of anhydrous AlCl3. Again the same role, the role of Lewis acid, the same reaction called as Friedel-Crafts with the name of Friedel-Crafts acylation. That was alkylation. This is acylation. Friedel-Crafts acylation. What do you get it as? CH3 C double bond O plus that attacks on the benzene ring. Again the same ortho and para. CH3COCl in the presence of anhydrous AlCl3, and then you get it as ortho and para. Ortho and para. This is how it's going to be. Right, sir? Or Friedel-Crafts reaction, both are done. Similarly, fourth reaction, I just do it say Cl2 in presence of FeCl3. Again that same rule, sir. FeCl3 acts as Lewis acid and it results in the formation of Cl plus FeCl4 minus. Again this Cl plus is an electrophile and that attacks the benzene ring. The reaction name is called as chlorination. Now there could be many such names, many such reactions. Important here is that plus R effect tells me I am gonna be orthopara or meta. This is my first chapter, haloarenes. Sir, my second chapter in class 12th is gonna be alcohol, phenol and ether. Alcohol, phenol and ether. Alcohol is going to be aliphatic, so we don't talk about it much. Phenol, again, benzene with an OH. And any OH group is going to be with a lone pair, shows plus R. So benzene reactions will happen at ortho and para positions. Reactions will happen at ortho and para position. So this is how it is useful. This is how this basic concept of plus R and minus R I'm so sorry becomes useful. That is, sir, if I want to do here bromination Br2 aqueous, this is actually an exceptional reaction here. So it comes on ortho and para, but it comes on all three positions. Beautiful reaction. All three positions. We name it as 2, 4, 6 tribromophenol. And it's actually a white PPT. 2,4,6 tribromophenol. It's a white PPT, sir. Right? 2,4,6 Br2 aqueous. Similarly, in case of phenol, nitration that I do in terms of phenol, nitration that I do, which is conc HNO3, conc H2SO4, same reaction happens but at all three places. That is OH, nitro, nitro, and nitro, which means 2,4,6 trinitrophenol. 2,4,6 trinitrophenol. So this is how orthopara helps you. This is how orthopara helps you. Similarly, within the same chapter, when I talk about, okay, you can copy it first, not a problem. Quickly, let us copy it first, not a problem, sir. Let us copy this once. Copy, copy, copy. I'm so sorry. Copied, sir. Right. If it is copied, quickly, what I want to tell you is that even now, when we talk about ethers, we say benzene with a OCH3. The name is called as anisole. And with anisole, that O has a lone pair, and presence of lone pair makes it a plus R group. Plus R group. Anyways, this OCH3 is actually called as methoxy. Not a problem as such. We will discuss that once we are in the nomenclature also. And then here any reaction, sir, I want to do Friedel Crafts. Alright, so it's CH3Cl in presence of anhydrous AlCl3. Sir, it's gonna be plus R. So what is gonna be my answer? Array orthopara, sir. Array orthopara, sir. And that is how it becomes really, really simple. Orthopara, sir. Why? Because, sir, it's gonna be plus R. Plus R means increased electron density at ortho and para positions, and therefore electrophilic substitution happens at these positions only. Why? Because it is happy. Negative charge and gets on the ortho and para positions. So this was my second chapter. First chapter haloarenes plus R. Second chapter phenol and ether plus R. I get to my third chapter, which is aldehydes. Third chapter, which is aldehydes, ketones, and carboxylic acids. Now, in this case, this is a peculiar chapter of minus R effect. That is, you see, benzaldehyde. Minus R effect, it means it is deactivating the orthopara positions. So here, very limited reactions. If I do nitration, conc HNO3, conc H2SO4 should happen at meta position. Why? Because it is a minus R group. So it's going to be meta nitro benzaldehyde. And that is how you do it. Meta nitro acetophenol in that sense. So that is how you make it out. You have to understand, you know the concept plus R, you know the answer. You know the concept minus R, you know the answer. There is nothing in between. It's either plus R or minus R. That's it. Chlorobenzene, once we do more in detail, it's gonna be minus I versus plus R. But we value plus R more. So ma'am, please, you go with orthopara. Not a problem. So my third chapter, class 12, is actually minus R. So results are clear, sir. Meta-directing, not a problem for me. And fourth chapter, which is aniline, amines actually. So here, amine with benzene with a NH2 is called as aniline, and benzene with NH2 has a lone pair. So it is gonna be a plus R effect. And plus R effect means it's gonna be orthopara directing. Remember guys, it is always the electrophile that attacks the benzene ring. Note it down. It is always the electrophile. It is always the electrophile that attacks the benzene ring. That attacks the benzene ring. It is always the electrophile that attacks the benzene ring. Why? Because benzene ring itself is a high electron rich compound. High electron rich compound, and therefore nucleophile stays away from it. Right? High electron rich compound, therefore nucleophile stays away. Nucleophile does not attack. Simple, very, very simple, sir. I am electron rich. So nucleophile is itself electron rich. Like charges repel each other. Sorted, sir? This is sorted. So once I am clear about what is minus R, what is plus R, you are through 50% of the reactions in your entire syllabus. Through 50% reactions. Because in benzene, it's going to be always electrophile. But it's always electrophile. Only two cases, it's going to be plus R. So orthopara, minus R, it's going to be meta. Nothing in between. Right, sir? Right, sir? So I think we have filled almost 5, 6, 7, 8, 9, 10, 11, 12. Whoosh, 20. Wow. We are on 23rd page of our notes. Beautiful. Right, sir? Correct. Just one more thing here. You will see two types of reactions happening. One is addition reaction. Okay, elimination will definitely happen. And one is your substitution reaction. I am saying in case of things coming in. Addition reaction, substitution reaction. Sir, when I say addition reaction, it is my, what should I say? Double bond or say triple bond. My bond order reduces. Or what should I say? My saturation decreases. In terms of, I tend to move from say triple to double to single. That is pi bond breaks. When I'm talking about addition reaction, I want to break the pi bond. Example, alkene. Example, alkene. If it comes to alkane, this will be called as a addition reaction. This will be called as a addition reaction. That is, some pi bond breaks. Important. Substitution, it's nothing is breaking. Substitution, only replacement oblique substitution happens. So guys, remember, the original molecule does not change. Original degree of unsaturation does not change. Original degree of unsaturation does not change. Original degree of unsaturation does not change. Important, sir. In case of addition, there will be both nucleophilic addition, electrophilic addition. Although electrophilic will be less, but you get both. Substitution also, nucleophilic substitution. Again, of the two types, nucleophilic substitution and electrophilic substitution. I'm talking about substitution, okay? Nucleophilic substitution and electrophilic substitution. Similarly, in the nucleophilic substitution, you get two types, which is SN1 versus SN2. Maybe some of you would know about it. I'm not covering it today for sure. You have another class at 8:30 as I understand. So I'll not take more in detail, but I'm just finishing it in next 2, 3, 4 minutes. That's it. So what I'm telling you is SN1, SN2. Electrophilic substitution, generally we don't cover it as any 1 and 2. It's through electrophilic substitution. Yes, aromatic and aliphatic is different, that we talk about. Addition reaction, mostly you will come across in your syllabus as nucleophilic addition reaction. And obviously, last but not the least, the third type of reaction will be elimination reaction. Elimination reaction, where it is the reverse cycle, something gets eliminated. There also it's going to be two type. It's E1 and E2. When E2 is one step elimination, and E1 is your rearrangement can take place, because we talk about a lot of hydride shift and everything, and therefore we need to understand when it is allowed, when it is not allowed. Rearrangement can take place. Right, sir? Right, sir? So this is where we sum up our first a little long 3 hour session. It's supposed to be a 6 hour organic. So there will be two sessions basically, three today and three tomorrow or day after. We will figure that out. So this is how you have to see the basics of organic chemistry when you start reading the NCERT. It's a mix of 11th and 12th text. Enough notes to figure out the basics other than the nomenclature. Nomenclature, yes, it demands special attention. That also we will do. But moving forward, the basics of organic chemistry are really important to at least kickstart your reading of general organic chemistry, of hydrocarbons, or even per se of haloalkanes and haloarenes. Any chapter that you read, you should understand this basic of what is inductive, what is resonance, nucleophile, electrophile, heterolytic, homolytic, all the basics that you require have been covered today. So take a glimpse. If it was very slow, watch it in 1.5x, 2x, whatever suits you best. But do watch this video for sure to increase your, what should I say, to, freshen your concepts of basics organic chemistry, basics of organic chemistry. Right, this was the first session that we had on it. We will have one more to summarize more reagents, more, what should I say, more properties, physical properties, more of chemical properties, the mechanisms, SN1, SN2, E1, E2, those mechanisms, then hydride shift, methyl shift, all those things happening around organic chemistry. And then we summarize that as well. Right, a little long session, 316 hours, 3 hours 16 minutes, planned for 3 but 16 hours extended. But anyways, that's, thank you so much guys for being persistent on this session. Again, if you find it useful, quickly watch it one more time, if required rather two more times, because you have that time for the NEET exam. For now, quickly go through the basics so that you can take up the stronger concepts. All right, take care, have a very nice evening. Good night and God bless you. Bye bye.